All right, now I'm going to tell you about something called KSP. So KSP is just a special version of KEQ. So it follows all the same rules as KEQ. It's just a different flavor of KEQ. All right, so remember what a saturated solution was. Like, what's a saturated solution? All right, that means it just has dissolved all the solute that it possibly can at that temperature. And at that point, you're in equilibrium. Right? There's an equilibrium going on with the dissolved ions and the undissolved solid that's sitting at the bottom. Now, here's the kicker. Saturated solution is not necessarily a concentrated solution. And sometimes, that gets people's brains, because usually when I talk about saturated solutions, I always talk about using something that's very soluble, something like salt or sugar. Right, if you take a spoon of sugar and go put it in a cup of water, it dissolves easily. Take another spoon and keep on going. Like, you can put a lot of sugar into water. It takes a lot of sugar before you start seeing a mound of undissolved sugar in the bottom of your glass of water. But you'll get there, right? And that's a saturated solution. Other things, if I take like a grain, like tiny, like a smaller than a piece of sand you'd find on a beach, and put that into a big old container of water, you're not going to see anything going on. It's like, nope, it's still sitting there. It hasn't dissolved at all. Well, that's not quite true. It maybe did dissolve, but just a really, really, really tiny amount. All right, something like iron sulfide. All right, this stuff is not very soluble. If you put this into water, you will dissolve some of it, but it's a really, really, really small amount. The actual concentration of these ions is exceedingly small, but that's all it takes for this equilibrium to be established. All right, so remember, that's what equilibrium is when the rates are the same. So this thing's dissolving at the same rate it's precipitating. All right, and so it just takes an extremely low concentration of these ions in the solution to hit that point. So we can have very, very, very not concentrated solutions, very unconcentrated solutions, and have this happen. All right, so we have this heterogeneous equilibrium going on, right? There's solid over here, there's aqueous ions over here. All right, so we write that like that. You guys should be able to write KEQ for this thing, right? So the equilibrium constant expression, its products or reactants, the coefficients become exponents, and solids and liquids don't go in, right? So here's my products over the reactants. Ooh, wait, that's a solid. It doesn't go in. So so we're just going to have the concentration of the iron times the concentration of the sulfide, right? The coefficients are both 1. So it's going to look like, come on, boop, it's going to look like that. All right, so what we're looking at here, our equilibrium constant is basically just the product of the ion concentrations, right? And these ions, the amount you have in your solution kind of depends on the solubility of the stuff. And it's just the product of these ions. Your KEQ ends up equaling the product of those ions. So they give it a special name. It's the solubility product constant. K stands for constant because chemists can't spell. All right, so KSP, it's the solubility product constant. It's KEQ, but for a sparingly soluble salt. For a salt that normally when you look up on a solubility table and you see things where it's like, this is insoluble. That's not quite true. It might not actually be insoluble. In fact, most things are not truly insoluble. They're just sparingly soluble. So none of it really dissolves. Nothing to be overly concerned with. All right. So KSP, the textbook definition here. So KSP of a substance is the product of the molar concentration of its ions in a saturated solution, each raised to the power that is the coefficient. So coefficients become exponents, right? The key thing here is that it's the concentrations of the ions in a saturated solution, so not an unsaturated solution. All right, so that is that, and these are tabulated. You can look up KSP values for all sorts of things, and take a peek at some of these, right? I mean, the biggest number on here is down here, calcium sulfate, 7.1 times 10 to the minus 5. That's a very small number. So the smaller this number is, the less soluble it is. And that's already a really small number. Look at some of these. Look at this one, 1.1 times 10 to the minus 49. That's 0.000, like 48 zeros, 1. It's insane. This is really, really not very soluble. The other thing you need to know, you guys need to be able to break these things up properly. If you can name them, you know what to break it up into, right? If it's magnesium hydroxide, okay, I'm going to break it up into magnesium ions and hydroxide ions. Manganese carbonate, manganese 2 carbonate would be this guy. But you need to know what to break these things up into, like Ag2CrO4. Like, I see people sometimes just split things willy-nilly. They'll make like Ag2, Cr, and then O4. Like those are three different things. And no, that's very much wrong. So know your polyatomic ions, know what these things break up into. It's going to really, really help you out. We will work some examples in class of KSP problems. They're kind of fun. They can be a little tricky though sometimes. So hang with me. I'll see you there.